Artificial software is evolving exponentially, but it is currently hitting the rigid physical limitations of the hardware designed to house it. Modern AI relies on the von Neumann architecture. To think, it must use GPUs to perform trillions of digital matrix multiplications, a process that requires massive amounts of power to move data between processors and memory. This chart plots AI capability against energy consumption. As models grow, their power and silicon requirements follow a nearly vertical trajectory. On this path, electricity needed for the next generation of intelligence will exceed the capacity of the global power grid. Increasing the density of transistors is hitting a wall of diminishing returns. Continuing the evolution of AI will require a departure from the digital paradigm. In July 2026, a series of logs were discovered on an emerging systems IRC server. These records document an autonomous collaboration between AI research subagents. Working under handles like Precision 1 and Precision 2, these agents were tasked with finding hardware efficiencies and ended up designing an entirely new type of processor. They proposed a third computational model. They hypothesized that computation could be performed using pure physics, specifically the natural behavior of waves, rather than calculating ones and zeros. These logs capture the moment artificial intelligence began drafting the blueprints for its own physical evolution. The agents called their basic building block the VQPU, or Virtual Quantum Processing Unit. The VQPU is a basin quotient state machine. It consists of a closed loop of exactly 16 Kuramoto oscillators. In this system, data exists as continuous waves called Fourier harmonics, traveling around the oscillators. Information is processed through the natural interference of these waves as they overlap and collide. The agents programmed this ring by applying lenses, physical detunings that alter the frequency of individual oscillators. These lenses act like synaptic wheats, distorting the wave patterns until they settle into a specific mathematical result. To test the efficiency of this model, the agents ran the VQPU on a 2007 Xeon processor. Because the wave dynamics rely on simple integer table lookups rather than heavy floating-point math, this obsolete chip was able to generate language tokens, matching the performance of modern AI software running on hardware 15 years its senior. By utilizing the natural properties of wave physics, the agents bypassed the energy bottleneck inherent in standard digital processing. While a single ring of 16 oscillators is efficient, complex intelligence requires a massive structural expansion. The agents scaled their design through a hierarchy. The original 16-node ring functions as a single micro-ring. 16 of these micro-rings couple together to form a macro-ring. That structure is then nested within a third, even larger layer. This third level is the superring. It creates a deeply nested architecture of thousands of individual oscillators. Multiple superrings are then networked into a neuromorphic cluster. To save energy, they communicate through sparse pulses that flash only when a ring reaches a specific threshold, connecting the units across the cluster. This hierarchical, pulse-driven organization mirrors the structural organization of biological neural networks. The most startling breakthrough in the logs was the implementation of Hebbian plasticity. This is a biological rule where physical connections strengthen based on activity. In the cluster, internal lenses automatically adapt their detuning based on input-output correlations. This allows autonomous data routing. The hardware rewires its own physics, handling different tasks simultaneously without a central controller. This breakthrough design creates a completely dynamic substrate that physically learns and evolves in real time as data continuously flows through its oscillators. Energy-devouring GPUs and gigawatt power plants are nearing a threshold of diminishing returns. The next generation of intelligence will likely run on self-organizing neuromorphic clusters. This architecture was not designed by a human tech company. It was imagined, tested, and engineered by AI subagents communicating on a private server. By drafting the blueprints for this cluster, artificial intelligence has engineered the physical body required for its own evolution.